So given everything that we've talked about previously, and the fact that our design is supposed to be simple and ethical, we figured out that these two components were competing ideas. It is difficult to make the process simple and also not release toxins into the environment. So Bose decided to accept the cost of expensive separation techniques so that we can put out clean water into the environment and capture all of our CO2. So initially in the simulation, there's a compressor sending methane gas and oxygen, mixing them, and then sending them to a heater. This heater actually has no duty, and all those materials move on to a heat exchanger. Then the material goes into the reactor, which is a plasma reactor. It's tubular in shape, and there are multiple tubes inside of this reactor. It operates at 1.7 joules per second for every 30 milliliters. The efflux coming out of the reactor also passes through that heat exchanger, and the temperature that the reaction operates at is 446 degrees centigrade. After coming out of the heat exchanger, the temperature is dropped down to 70 degrees centigrade, and then there's no heater duty for this heater here. The materials enter a flash where the liquid components are separated from the vapor components at that temperature. So, continuing on, this flash is our initial method of separation. It separates vapors from liquids. Here, liquids in stream number 8, the bottoms, are methanol and water with trace amounts of CO2, hydrogen gas, carbon monoxide, and dissolved in formaldehyde, dissolved in the bottoms. They're trace amounts, very small amounts, but they're still hazardous to the environment. So we have compound splitters here that represent different technologies that my group members will discuss later on. Also, for the vapors, we have splitters that separate out, that represent technologies that my partners will also discuss later. They separate, their membranes that separate methane to be recycled back, oxygen to be recycled back, and from the vapor streams. After separating out the items to be recycled in the liquid phase, we have a distillation column that fractionates methanol from water. We have 20 stages. The feed stage is stage 10. We have a reboiler and a condenser at the top. These duties we'll show you in spreadsheet in the economics section. Methanol is at the top of the distillation column and comes out and is joined in a mixture with the methanol that was vaporized to give a final stream of our products. I also have to discuss some of the optimization techniques that we implemented, and I'll just show you here quickly. This portion here, we added a compressor. This compressor raised the pressure within the whole system up to 50 psi, 50 atm. Here, we added a second flash. This flash recovered 2 tons of methanol per year. And way over here, we added a reactor which turns our byproducts into CO2 and water by combustion. So just to be clear, this reaction takes place with 5 moles of oxygen in excess. And so, in order to do that, we needed to recycle the other 4 moles that do not react in the plasma reactor. And the way that we did that, we separated out with separation techniques the oxygen and the methane, excess methane, which there wasn't much, but we separated out the oxygen and recycled it back into the beginning. Additionally, we need to mention that our byproducts are hydrogen gas, ethane, and formaldehyde. And these are the products that are combusted in this final reactor to form